Hi, students. So you can see that no one has actually asked questions about our Unit 7 formative yet, but I thought that I would get a jump on some of those questions and look at things that people often got wrong. So I've got my AP Classroom window open up here, and you can see these questions here. This is questions 5, 6, and 7, I believe. This interface is so terrible. 1, 2, 3, 4, 5. Oh, 6, 7, and 8 were the questions that were most often missed, although this is a bit of a skewed sample because I have 4 people who didn't take it. But let's go ahead and look at some of those because I think those are the ones you're going to have questions about. So I've put them into a Notability Talk here. So this was question 6. And it gave you the slope field, and it said this is the slope field for the differential equation of y equals f of x. And we've got a particular solution through the point -1, 2. So here's the point. So this is sort of where I would be following my curve, it looks like, something like that. And then it asks for, it tells me h of x, let me make this bigger, is 3x times f of x. And we want to find h prime of -1. Well, h prime of x, that's product rule. So it's going to be the derivative of this is 3 times f of x plus 3x times f prime of x. And I want h prime of -1. So h prime of -1 is going to be 3 times f of -1. I know that f of -1 is 2 plus 3 times -1 times f prime of -1. So I come up here, I see that f prime of -1. Well, first I want to see how we're counting. We've got 1, 2, 3, 4 blocks to get 1 unit. 1, 2, 3, 4. So we're counting the same units. So I can just look at my slope, and my slope is -2. So we're going to have 3 times +2 minus 3 times -2. That's going to give me 6 plus 6 is 12. All right, this next one, this was question 7. So we've got a slope field for this diffie q. They give me the equation of the diffie q. Y equals g of x's solution with the initial condition g of -2 equals -1. So when x is -2, that'll be about there, -1. So I'm looking somewhere around here. So it looks like we're going up this way. And that's what it's looking like to me. Curves this direction seem like they're going that way. And then we also can see that we have a flat slope here. So it also looks like we have, I don't know what's happening down there. But we want the limit as x is going to infinity of g of x. So this looks to me that the limit as x goes to infinity is going to be the horizontal asymptote of y equals 0. So y equals 0 is my HA. So my limit as x goes to infinity, g of x, is going to be 0. So which of the following is a curve that intersects at right angles? So that's telling me that I'm looking for perpendicular tangents. So I'm looking for normal curves of the family y equals 1 over x plus k. K takes all real values. So I want the equation of a curve that is going to have a slope that's perpendicular to the slopes of this. So first of all, I need to figure out what my original slopes are. So dy dx is going to be, this is y equals x to the -1 plus k. So when I take my derivative, I'm going to get -1 over x squared as my slope. So then perpendicular slopes, so now I want perpendicular slopes. So I'm going to get curves that have slopes of x squared because I take the negative reciprocal. So I want a curve that has this as its slope. So coming back and looking at my options, so now we're looking at the next question. So if I want curves that have positive x squared as the slope, then this is going to be my option, because when I take the derivative of this to get the slope, I'm going to have x squared. So I want this slope. That means I needed to have an original function that's 1/3 x cubed. And then I could have had some sort of constant plus c. All right, I hope that helps. Add questions to the document, and I'm happy to talk about more things.